the OEM Apprenticeship, it covers a wide range of modules, you know, across a lot of subject areas, and in those modules there's a great commonality with them, that one module kind of complements the other. So I'll just start off the video here and let you see how we progress. So the first module really that we cover is health and safety, and as we know, health and safety is paramount in any industry, and topics that's covered during health and safety are the like of the legislation regarding the Health and Safety at Work Act 2005. The students learn how to write up accident reports, risk assessments. They learn about the use of pulleys, chains and slings, working at heights, working in confined spaces. They also learn about, you know, lockout and tagout, making things safe, making things secure, and also understanding the employer's responsibilities and the employees' responsibilities. That it's not just, you know, it's somebody else's job to clear this up or to fix this fault, that everybody has responsibility for themselves and others when they're working in their OEM environment. And we also in regards to health and safety, we also get them to do a manual handling training course, and we also get them to do in-house health and safety courses as well online, which are they're awarded a certificate at the end through the Health and Safety Executive of Ireland. So that's our health and safety module. As you can see here, here's more practical module here, which is our OEM Practices, which is a very hands-on practical module. And in this, the students are learning about the disassembly and reassembly of parts and components, the removal and replacement of parts, learn to use the correct tools like measuring tools, like torque wrenches, how to set up a torque wrench, how to store a torque wrench after its use. And they work on a variety of different kind of components here. This is removing and replacing here. So they work on different types of engines, gearboxes, hydraulic pumps, electric motors. So they're getting the basic hand skills. So they'll be able to, you know, transfer the knowledge that they've learned in theory in the classroom to the practical. So transferring the knowledge from the head to the hands, as I say. Getting to know different types of fasteners and fixings, the like of Allen key bolts, torxes, security torxes, hex heads, and such like. And then on one of our core modules is the mechatronics here. And as you can see here, the guys are working on hydraulics here, and mechatronics covers a wide subject matter. It covers hydraulics, as I say, pneumatics, the automotive engine system, battery systems, and mechanical drives as well. So there's a fair in-depth subject matter there in regards to mechatronics. And as you can see, the guy behind the guys there is one of our hydraulic rigs, and we also use simulation software where they get to actually draw hydraulic circuits, understand the symbols, and understand fault finding in regards to the hydraulic systems. In the automotive side, they're learning about the two-stroke cycle, four-stroke cycle, the different systems and subsystems like cooling, lubrication, exhaust, engine management. Then we introduce faults into our rigs, both hydraulic, pneumatic, and automotive, where the guys have to do a diagnosis and repair so that they're doing a first-time fix to get it right first time, every time. Another one of our modules here, as you can see, is electrical and electronic technology. And this is where we start off introducing basic electricity, because a lot of students maybe know nothing about electricity. They mightn't have done anything at physics at school, etc. So what we start off here is the basic circuit, the water analogy, showing them, you know, pressure, flow, and restrictions, where that'll be our volts, our current, and our resistance in ohms. So we start off getting them to build a simple circuit first. We start off with one bulb, two wires, and a battery. And once they have that done, then we progress then to series circuits, parallel circuits, series parallel circuits. We introduce them to the use of the multimeter, how to diagnose voltage, current, resistance, voltage drops, etc., which is a great skill for any apprentice in the industries that they're employed with, because where I see them is a kind of a diagnostic technician in the future. So we'll introduce faults into their circuit boards as well, which they have to diagnose, which gives them confidence going forward when they're back out in their workplace. We also, in electrical and electronic technology module, we cover electronics. So the students get to grips with the different types of electronic components, such as diodes, capacitors, resistors, and we do the whole Ohm's law and Watt's law theory there as well. So they understand how to calculate the resistors in series, resistors in parallel, capacitors in series, capacitor in parallel. They learn it in the theory side, and then we put it into practice here where they build circuits both on breadboard, and also then we get them to transfer it then to strip board, which is very good to enhance their soldering skills and to be able, if they went to an electronic component such as an ECU or a control panel or a body control module, anything like that there on a machine, that to be able to identify electric dry solder joints, etc., be able to remove and replace components and test components. So one of our core modules here, as you can see, is engineering drawings. And like every good idea, it starts in some brilliant mind, and then what do? We put pen to paper. So we have to engineering drawings. Then it gives the students the opportunity to learn freehand sketching and also the use of SolidWorks or AutoCAD, whatever type of software they're using in the college. We have both here, and whatever type of software you're using in your company, they will have a great foundation in this module, which helps them to develop their freehand sketching and also their use of using different types of projections, isometric, orthographic, be able to do bill of materials, designing like a chassis systems or components, let them be chassis components, suspension, or whatever it is that is in your company. They're getting a great foundation in regards to engineering drawings. As you can see there, some of the students are quite brilliant with their freehand sketching. I can't claim any of them, they're all their own. And the lack of SolidWorks here is very valuable to each student going forward. Another one of our core modules here is operations management. And as we know, operations management is very, very important in the modern era. So what do we cover in this module? We cover the lack of SIPOC diagrams, fishbone diagrams, lean management, Lean Six Sigma, the Kaizen principle, and also how to reduce waste, how to upskill, and how to produce better time management that there's good throughput, good productivity within the company. And the guys also have, the second year guys have also completed their yellow belt this year, and going forward we hope maybe next year to be able to get them to do their green belt as well in operations management. This is our testing and measuring module here, where we introduce the guys to the use of test tools like multimeter and mega tester, where they're doing volt drop testing, where they're testing winds on DC motors, AC motors, the health and safety around these, so that they'll be able to know that a component is faulty, and they can get in the relevant personnel to replace that, to try and reduce downtime and to make sure that productivity can be kept up to speed. So they'll do a wide range of testing here in regards voltage drops and resistance to kind of get a right force time, or what would you say, force time fix, so that they follow the proper procedures when they are doing diagnosis and testing. Here in our hydraulic rig here as well, this is another part of testing and measurement, and also it crosses over into mechatronics and analytical and problem solving, because as I said earlier, we introduce faults here into these panels that the students have to diagnose and repair themselves. So if you see there, we have the electrical side, we have the mechanical side, and just there to the left of that, just a wee bit out of shot, is the PLC side, where we're introducing the electronic side, where going forward in year 3 they'll do industrial robotics and PLCs, where they'll learn about PLCs in regards inputs, processing and outputs, learn to do ladder logic and the ladder diagrams, and be able to test, diagnose and repair those systems as well. This is another one example of our analytical and problem solving module here, where the students are building a hydraulic circuit that had a built-in fault simulated by a restriction valve, and then they have to diagnose it themselves. I think one of the ones coming up now soon is where there was a fault with a motor and they were successful in getting this fault rectified, which gives confidence to them, helps their analytical skills, helps their diagnostic skills, be able to make a kind of a flow chart diagram. They write it out step by step to know what steps to follow. If you have a good thorough diagnostic process, well then you're going to get a right force time fix. Here again, if you just pause again 1 second here, just to let you see here, this is one of our other training rooms in the Mon Institute, and we have purpose-built panels here. To the left we have our pneumatics, just to the middle there we have our PLC, and then we have motor control as well. So we have a selection of PLCs there, we have AFM, we have Mitsubishi, then we have motor control here as well. And like I said, in the PLCs there, we're introducing them to the basic PLC function. I would compare it to, like their own brain, this is where all the processing is done, and their arms and their legs is their actuators, and their sight and their sound is their sensors. So that's where I kind of bring it back to kind of something that they can relate to, like a light A light is something that switches on with a switch, and a light, but the computer's just in between making it work. So PLCs, industrial robotics as well. Industrial robotics is where we are introducing them to robotics in the OEM environment. Where robotics fits in the OEM environment. In the lack of robotic welding, robotic spraying, and where robotics and the human operator can work in unison, because we know they have to be able to work hand in hand if companies are to be successful. Also, here's just another example of our analytical and problem solving, where there was a built-in fault in this engine rig, and the guys had to diagnose it and repair using various test tools like the multimeter there, and also I think a spark test tool coming up as well. And as I said earlier, these whole modules have a kind of a commonality, so they all complement each other. Like mechatronics will complement analytical and problem solving, electrical and electronic technology will complement testing and measuring, and PLCs, etc. So they get a wide range of modules, they get a variety of subject matter to try and instill a lot of I suppose hand skills, technical skills, electrical and electronic skills, and fault finding skills. And just as you look there now at a few of the fade-ins, I just want to also say, apart from the main core modules that they do, the practical and electronic ones, there's also 3 underpinning modules, which are team leadership, communication, and applied engineering, which also enhances their calculating skills, their presentation skills, their writing skills, interpersonal skills as well, to further enhance them and to make them a better apprentice and a better employee for you in your workplace.